Okay, so the first thing when you're talking about algebra, Unit 1 of algebra was for you to be able to add, subtract, multiply, and divide all kinds of numbers. So when you were in algebra, Unit 1 was all about expressions. And when you learned about expressions, the biggest thing that came out of that is, do you know how to combine like terms? So Unit 1 basically had no equal signs. We didn't worry about equal signs, just following the order of operations and combining like terms. In algebra, when you had Unit 2, that was where you learned how to solve equations. And when you learned about solving equations, that's when you learned about all your properties of equality, and you learned about how to simplify different sides of the equation and work your way down to having a value for x. Unit 3 of algebra was when they started to introduce to you the idea of functions. And they talked to you about input, output, domain range, coordinate graphing, and different things that were happening then. Unit 4 of algebra is when we started talking about writing linear equations. Do you know how to write a linear equation? And that is where this review starts to pick up. If an ordered pair, and that's an x and a y ordered pair, is a solution of the equation, that means that this input and this output value make that equation true. So if that xy ordered pair is a solution, then when I substitute it in, I get a true story. So instead of writing y, I'm going to put what y is equal to. Instead of writing x, I'm going to put what x is equal to. And then I use my Unit 1 simplifying expression skills to go ahead and see if I end up with a true sentence. If I end up with 8 is equal to negative 12 plus 4, is 8 equal to negative 8? Yes or no? No, because of this negative. So no, therefore, it's not a solution. If an xy ordered pair makes an equation true, when you plug it in, you get a true sentence. When we get to the next point, we talk about, given the following endpoints, find the midpoint, slope, and length of the segment. And that takes us back to our big three equations, because if I have two ordered pairs, I can talk about x1 and y1. I can talk about x2 and y2. And by looking at these, I can come up with 3 different conversations about these ordered pairs. Getting a piece of graph paper and knowing where these coordinates are is very helpful. So when I look at over 0 down 4, I know that that ordered pair is on my y-axis. If I talk about over 7 down 3, I can go ahead and say that that ordered pair, now there is exactly one line that goes through those 2 points. We learned that in geometry. And there's 3 things I can talk to you about that line. I could talk to you about the slope. So little baby m is the slope, y2 minus y1 over x2 minus x1. That is my change in my y coordinates compared to the change in my x coordinates. The next thing I could talk to you about this line has to be specific to just the line segment. because when I'm looking for the midpoint, and we'll do our midpoint with a capital N, that's going to be the point that's in the exact center of that line segment. Our midpoint is going to be that point in the middle. And that's where I take my average of my x's and my average of my y's. I can't do that with a line. I can do a slope with a line, but I can't do that with the midpoint. I need a line segment. The last formula that we need is where I'm talking about the distance from one coordinate to the other, and that represents our distance. Our distance is always going to be equal to the square root of the difference between my x's squared plus the difference between my y's squared. A couple of you are struggling sometimes on the distance because you wind up with negative values. Please understand, this is always going to be a positive value. When I take the square of a negative, I will wind up with always a positive plus a positive. You're not going to have a negative value because when you square it, a negative times a negative is always a positive. If you're curious why it seems familiar that you've already done this, your change in y and your change in x's are a part of that slope conversation. So for 5, 6, 7, and 8, working on distance and midpoint and slope shouldn't be too tricky. When we talk about 9, 10, 11, 12, 13, and 14, we're talking about solving or writing a linear equation. And I'm going to come down here and add some extra notes for us, because when we talk about writing linear equations, well, let me spell it right first, right? Writing linear equations. The biggest thing that you have to understand is that all linear equations are in the format of y is equal to mx plus b. This is called our slope-intercept form. We're not creative when we name things in mathematics. Our slope-intercept form is the one where we have the slope and our y-intercept. Every time that we write an equation, our x and our y have to be open. Those are open variables, because what I need is an infinite number of x, y ordered pairs that I could plug into here to make it true. And that's what you tested up at the beginning. If your intercept is given to you here, here, and here, finding the slope can be a little tricky because you need another point. If you have the point and no intercept, your first choice is to find the slope and then solve for the intercept. So whatever you have and what you need is what you need to find.
Interruption, but we would like all seniors who have not picked up their senior class T in the lecture hall to please report to the lecture hall to pick up your senior.
So I'll do one of each of these because in each one, you're missing a critical piece of information. All right, so if I start off here with my y is equal to mx plus b, I plug in what I have, and I solve for what I'm missing. I have an x, I have a y, and I have a b. So negative 1 is equal to my slope times my x value minus my 5. Now that I have my stuff plugged in, I know that that's how I'm going to be able to find my slope. When I go to solve, negative 1 is equal to negative 2m minus 5. If I add 5 to each side, 4 is equal to negative 2m. Divide by negative 2. So my m is equal to negative 2. When I go to write my equation, I have everything I need. I have my slope because I solved for it, and I have my b because it was given to me. Negative 5 is my b. Negative 2 is my slope. So when I write my equation, y is equal to negative 2x minus 5. If I look at something like problem number 13, I need to first find my slope. My slope is equal to 2 minus negative 3 all over 1 minus 6. The difference between my y's, 2 minus negative 3. The difference between my x's, 1 minus 6. My slope is equal to 5 over negative 5 or negative 1. When I go to solve using y equals mx plus b, I plug in what I have and I solve for what I'm missing. I have an x and a y, and it's my choice which one I want to use. Here's my x and here's my y. So my outcome of 2 is the result of my slope, negative 1, times my input of x plus my b. Now I can solve for what I'm missing. 2 is equal to negative 1 plus b. b is equal to 3. Once I find my slope and once I find my b, I can plug that into my equation. Y is equal to my slope and my intercepts plugged in. My slope is negative 1 and my b was 3. And there's my equation. So I want you to look at these and try these, and then come back with questions. We'll talk more in class.
Y equals negative x plus 3, or do you have to put the 1 there?
You can simplify this, absolutely, to y is equal to the opposite of x plus 3. 100%. When we look at what's on the back, we want to think about using the distributive property and multiplying each thing by what's inside. Remember, if I'm multiplying x times x, that leads me to an exponent where I have 2 factors of x. When I'm multiplying polynomials, that's when your teacher last year hopefully told you about FOIL, which is a nickname for firsts, outers, inners, and last terms. X times x is x squared. Negative 2 times x is negative 2x. 4 times x is 4x. 4 times negative 2 is 8. Most often you will find that these middle terms can be combined, and you can write it simpler as x squared plus 2x minus 8. That is a quadratic trinomial. That's the product of those 2 binomial factors. For our greatest common factor, we're trying to figure out which factor can be divided out. And factoring polynomials and simplifying radicals, we'll talk about more in class.